side of 15 and add to 8. And they have to be the same number. So first, I would always think of like what two numbers multiply to 15? 5 and 3. What other numbers multiply to 15? There's two other numbers. They're obvious ones. 15 and 1, right? And so out of those, which ones add to 8? 5 and 3. Ding, ding, ding. So I put positive 5 and positive 3. That's all we're doing. It gets a little bit complicated when you have to multiply and add to a negative number. So I'm going to clear that screen. Let me clone this a couple times. Okay, next one. Next one is, let's go to a negative one. So let's go to number 4. So it says -8 and 2. So first of all, what two numbers multiply to -8? -4 and 2. What else? -8 and 1. What else? Don't forget to switch them around. So -2 and 4, those aren't the same. And -1 and 8. So one of them has to be negative to multiply to a negative number. Out of those, which ones add to positive 2? -2 and 4. Ding, ding, ding. Does that make sense? So it's almost like a little puzzle. All right, let's try 5. So 5 was -20 and -8. So what number do we need to multiply to? What is it? Well, we're multiplying to -20. So we have 4 and 5, but we need to make one of them negative. And then we could also do this. What else? Multiplies to -20. -10 and 2. What else? -2 and 10. What else? -20 and 1. And -1 and 20. You don't need to list these every time. If you're like pretty good with your multiplication facts, you can just go ahead and do it. But this might help just to figure out, okay, now which one of these adds to -8? -10 and 2. And notice when we're adding to a negative, right, the bigger number, the bigger absolute value is usually negative. So right here, see how 10 has the negative and this is negative? And before right here, since this is positive, 4 was positive. So it's kind of like a little trick. You don't have to memorize it, but it's a good way to figure out, okay, if I'm adding to a negative number and multiplying to a negative number, the bigger number needs to be negative. Let's try number 6. So 6 and -5. Now we're adding to a negative number, but multiplying to a positive. What does that mean about my two factors? They're both going to be negative. So Tristan, give me two numbers that multiply to 6. But they have to be both negative. -3 and -2. What else multiplies to 6? -6, -1. Out of those, which ones add to -5? Yeah, because that would add to -7. Ding, ding, ding. So we know when we're multiplying to a positive added to a negative, they both got to be negative. Cool. Let's do one more, and then you're just going to practice on delta math. So we're multiplying to 18, so adding to -9. This is number 7. So what does that mean about both my factors? What are they going to be? Negative, right? So maybe start off with this. Okay. What two numbers multiply to 18? Give me 2. Negative, what did you say? Negative 9, negative 2. What else? And but they're the same thing. They're still negative 2, negative 9. Now it doesn't even matter because they're both negative. What else multiplies 18? Negative 18, negative 1. What else? One more that you guys are missing. Good. Negative 3 and negative 6. Those two add to negative 9. Does that make sense what we're doing? Does everyone feel okay with it? Like they get to do it on their own? Okay, so what you're doing now is just for practice. Like this is just like almost a drill and kill, like where you just have to keep doing it over and over again. And so that's all we're doing for this class. Next class we'll be actually factoring. So you're going to your Delta Math, and it says X game practice right here. So there's 3 levels. All you're doing is like they're telling you the 2 numbers. So like what 2 numbers multiply to 24 add to 11? What are they? What 2 numbers multiply to 24?
I've heard 2 of the right numbers, but people just didn't say them together.
Yeah. 8 and 3. I think Brandon just said it. Because 6 and 4 do, but 6 plus 4 is 10. And then I heard 12 and 2, but that's 14. And 24 and 1 is 25. So 8 and 3 would be my 2 factors. Because 8 plus 3 is 11. What about multiplies to 8, adds 9? Which one's easy? 8 and 1. Cool. So you're just doing those 3 levels right here. And they're not, the only difference is that like this one, they're multiplying to a negative. It starts to get to negative numbers, which you all know how to do. Cool. Any questions about that? I feel like this is pretty easy. Some of you guys just need to finish. So are all those terms on one side of the equation? No. How do I get 20, or how do I get 20 to the other side? Beautiful, I add 20. Now, is there anything to combine it with over here? No, so I just rewrite it. So remember, it goes x squared, then x, then the number. So first step I did was get everything on one side or in standard form. The next step that you do is label your A, B, and C. So step 2 is label A, B, and C. So looking at this, what is your A here? What's the invisible number in front of it then? 1, right? What's your B? God bless you. 9. And what's your C? 20. So step 2, after we get everything in order, label your A, B, and C. So step 3 is play the X game. And how we figure out what goes where is the top is your A times C, and your bottom is your B. So A times C is at the top, your B is at the bottom. So we set up our own X game now. It's always going to be the same. So what is 1 times 20? 20. So 20 is going to go up here. And then by B goes at the bottom. I just remember bottom starts with the letter B. So B is at the bottom. What is your B? 9. Cool. Then I need to figure out, okay, I need to play the X game just like I did during your ticket in the door. What 2 numbers multiply to 20 add to 9? 5 and 4. Ding, ding, ding. Positive 5 and positive 4. The next step is we need to make the box. So this is quite a lot of steps, but it will go a little bit quicker as we do it. So we're working backwards with the box method, where we multiply, but now we're not actually multiplying. So we draw our box. And so what we put here is your ax squared, whatever that term was, and your c still goes right there. The only thing that's different now are these numbers are the ones that are getting split up. So I'm going to draw the box right below it. So if I look at this right here, what is your ax squared in that original equation? What does it say? Up here. What's your a? 1x squared. I'm going to put that right there. That doesn't change. My c also doesn't change. What was my constant or the number by itself? 1. Those don't change. You always put your ax squared and your c, those same two boxes. What changes is now I'm splitting up this 9x. I split them up into 5 and 4 by doing the x game. So right here, instead of 9x, I'm splitting it up. So it's positive 5x and positive 4x, like that. Last step, step 5, is find the GCF of each row and column. So we're basically working backwards. We're figuring out, okay, what times what equals x squared? How you can do that easier is I look at these and I go, okay, what do they both have? What letter? X, right? And the GCF of 1 and 4 is 1, right? So I just can put x right there, or 1x. Then I look right here. What goes into both 5 and 20? 5, right? Then I do the same thing this way. What is both in x squared and 5x? The letter x. And what's the GCF of 4 and 20? 4, right? Because 5 is when we divide it. And so your factored form is just x plus 5, x plus 4. That's how you factor. So I made it a little bit harder with the box method, because that's how you do it when I wanted to show you the process when a is greater than 1, which I'll show you in a second. But see how a is 1 right here? They're literally just these two numbers. And so it's not going to be like that. If a is not 1, it's not going to be that easy. But when a is 1, it's as easy as just going to step 3 and then just writing in your factors. Does that make sense? Okay, let's go to the next example. So draw a line. And now we're going to try this one right here. X squared equals 16. So step 1 is everything on one side. Nope. How do I get 16 to the other side? Subtract it, right? And then I just rewrite it. X squared minus 16 equals y. Then I gotta label my A, B, and C. What's your A here? What's the invisible number in front of it though? 1. Now, B is the number that's next to X. Do I have a B here? Nope. So my B is 0. What's my C? Negative 16. Cool. Then I play my X game, right? So it's A times C and then B at the bottom. So I know B at the bottom, I know I'm adding to 0. And what's 1 times negative 16? Negative 16. So what two numbers multiply to negative 16 but add to 0? Anyone think of it? Four and four. And I know one has to be negative. And what's 4 minus 4? 0. Perfect. Now, since A is 1, I can just write it like this. And that's my answer. When A is not 1 is when we do the box method. But you can still do the box method for everything, especially during your milestone to play it safe. So when we are doing the box method, I take the first term and I still put first, x squared, my last term and still put it last. And we split this up, so now instead of 0, it's 4x and negative 4x. What does this have in common? What letter do they both have? X. And then what's the GCF of 4 and 16? Good. Plus 4. And what do they both have here? What letter? X. And they both have a negative sign, so I'm going to put a negative. And then what do they both have here? 4 and 16. What's the biggest, greatest common factor that goes into both of them? 4. Which is the same thing I get here, x minus 4 or x plus 4. To check your work, you just multiply. So I'll go, okay, let me make sure the box method works. X times x is x squared. Cool. X times 4 is 4x. Negative 4 times x is negative 4x. Negative 4 times 4 is negative 16. That's just how to check your work too. Does that make sense? Okay, let's try one more. I'm just gonna, should I just keep doing an A as one? Okay, so let's try another one. So let's do x squared. So this is another example. Plus minus x plus 30. No, minus 30. That's our next example, so you can draw a line. So we'll just work right now when A is 1. And then in a few minutes we'll do an A is 2. So step 1, Kamari, is what? First thing I do. Why did I not have to get it into standard form? It's already in standard form. Everything's already in one side. So step 2, A, B, and C. So Kamari, what is my A? What's the invisible number? 1. What's your B? Negative 1. And your C? Negative 30. Beautiful. Kristen, what's the next thing I do? The x gain, right? And so I know B is at the bottom, negative 1. And then I do A times C, which is negative 30. So I need to figure out what multiplies to negative 30 but adds to negative 1. Does anyone know it? Negative 6 and 5. Beautiful. Ding, ding, ding. So I can do the box method, but because A is 1, I just know it's x minus 6, x plus 5. So that's how you get it in factored form. That's why we played the x game. Are you guys ready to see when A is greater than 1, or do you want to practice this first? Which one? I'm going to show you one example when A is greater than 1, and then we'll see from there. So the last one I'll do when A is greater than 1. So this one right here. So this will be our last example we're going over. So draw a line. And so first step, is it in standard form? Is everything on one side? Yeah. Yep. Then I do my A, B, and C. Keandra, what's my A? 3. What's my B? And my C? Beautiful. Then Yaslin, what do I do next? Jaslyn, what do I do next? It's gonna take a while. X game. So B at the bottom. So my 17's at the bottom. Now we can see A is not 1 anymore. What's 3 times 10? 30. So what multiplies to 30 as a 17? You can shout it out. You get it. 15 and 2. Ding, ding, ding. Positive 15. Positive 2. So when a is greater than 1, you absolutely need to do the box. So I know my first term is 3x squared, so it goes right there. My last term is 10, so it goes right there. And now instead of 17x, I'm splitting it up between the two I just came up with, 15x and 2x. Now I just find the GCF of each column or row. So what do they both have here? What letter? X. So X this way. What about right here? What's the GCF of 15 and 10? 5. Beautiful. Then we do it this way. Now, what letter do they both have? X. But now they also have a GCF. What's their GCF? 3, right? 3 goes into both of them. And then 2 and 10, what's the GCF of that? 2. Perfect. And so see how now it's 3x plus 2? That's why we can't just write it down. These are our factors. And that's why we can't use 15 and 2 because it doesn't work out like that anymore. So we only can use that when a is 1. We can skip that when a is 1. Does that make sense? Yeah. Are you guys ready to try it on Delta Math, or do you want like a few extra practice problems on the paper? What do you say? Delta Math. Okay. So your Delta Math looks like this. Let me show you. And so your Delta Math is like this. It says factoring practice. The first one's just greatest common factor. So they want to know what the greatest common factor of these. So just practicing like what you would do in the box method. The second one is factoring when a equals 1. So it's already on one side. So you're just factoring. So you're just having your answer like it ends up being x minus 5, x minus 3. One second, Carla. And the last one is when a is greater than 1. So what we just did. So these are your 3. You have until like the end of spring break because we really want to make sure you get these 3 down. But we're giving you like a head start so that if you get it now, then you don't have to do anything over spring break. Does that make sense? This is the last thing from that unit 6 we didn't know if we were going to have time for. We want to make sure you got your test over with, but you do have to make sure you know how to factor. That is going to be like on your final and your milestone and all that. Does that make sense? Does anyone have any questions about what you're doing? Does anyone want like a paper version first to like make sure you can do it just like using paper? Cool. Raise your hand high so I can like print you out one. 1, 2, 3. Cool. I'll print you guys out one and you can do it on, I'll let you do it on paper if you want instead of doing it on Delta Math. That's fine too. But I would do the extra practice.